Hey, we got ourselves a squeeze theorem problem here. To help you visualize it, I already graphed 2x minus 1, that's the one in blue, and x squared, the one in red. And we can see what's going on here. So if I were to plug in 1 for each of those, then the y coordinate I get is actually 1. So 2 times 1 minus 1, that comes out to 1. And 1 squared, that also comes out to 1. So this is something where we'll be able to apply the squeeze theorem because they told us that f of x is in between those two graphs. So I don't know exactly what f of x is. It could be anything weird. Maybe it's just something that looks like this. But it's got to be in between these two graphs. So however I draw it, it's got to be something that's in between the red graph and the blue graph. Anyway, we need to figure out the limit as x gets closer to 1. Well, if you have the graph, it's very easy. But normally you don't have the graph. So let me just explain that whenever f is in between, let's call it g and h, if you can do the limit of g and it comes out to be the same thing as the limit of h, well then that means that your limit of f is going to equal the same thing that these guys are equal to. And in this case, instead of having g and h, well, we have 2x minus 1 and x squared. So I got to take the limit of x squared as x gets closer to 1. And this one is x gets closer to 1. But for both of those, I can just plug in. So what you'll end up getting for both of those is 1. So because that comes out to 1, and because they both come out to 1, that means that the limit of f must be 1. You can say that as you're approaching 1 from the left and 1 from the right, that you're kind of getting squeezed in between. And what are you approaching? Well, you're approaching whatever this y coordinate is right there. So that's it. The answer is 1.